Hi everyone, it's Steve here, and today I want to talk about this thing. This is an Atari 2600 video game joystick, and I've recently had to repair it. I've had to replace the cable because the other one was broken, and I've also made some modifications on the inside which makes this device a little bit more usable than it was back in the day. If you're like me, you hated this thing. It was a piece of junk. Nobody wanted to use it when playing video games, mainly because you always had to press really hard in certain directions to get things to work. And even that wasn't a guarantee that the response was going to be made with the character on the video game. Sometimes the fire button didn't actuate. And if you had to play some games on the Commodore computers, like the Summer Games or the Olympic Games series from Epix, and you had to jiggle the joystick back and forth really, really fast, it never worked. You can never get the timing down right, and it just ruined the gameplay. So let's crack this thing open. Let's see what's inside, why it sucks so much, and how to make it better. Here's the joystick opened up. There are 4 screws that basically hold everything together. Once you take these screws out, everything pretty much falls apart. The circuit board sits on top of the joystick like so, and the Spade connectors that are on the end of the cable basically clip in to the sides of these traces on the board right here. I'll get more into that shortly. This is a modified board, so it will not look like your board once you've taken yours apart. The fire button has a spring underneath it, and it basically sits on top of the fire button like so, and that's basically just used to give some recoil action when you press the fire button down in the joystick against the circuit board. And then finally, we have the actual joystick itself. There is a piece of plastic that fits into the joystick that limits how far left and right you can move. And if you were to remove this, wow, that's been chewed on a bit. Anyway, if you remove that, you can see that there's actually no resistance over here to hold this thing in place. One thing you can do with this is you can pop the actual silicone part out, and you can use it as a suction cup. Lots of fun when you're waiting for your games to load on your computer. Okay, let's take a look at this circuit board right now. I've got a zoomed up photo that will demonstrate how the thing works, and that'll show you the problems that are in the original design. Here's a close-up of the board that shows the traces and what's underneath these components I've used to modify the original board with. Effectively, what is implemented here are 5 switches. One for the fire button, up, down, left, and right inputs. And the contacts that go over top of these switches kind of look like this. I've used a piece of cardboard to illustrate what's happening here. They'll sit over top of a trace, and they're convex in shape, so they're only making contact with the outer portion of this arc shape for the trace. So I'll put this back here. Now, when the joystick actuates the signal, it will press down on this contact and flatten it. So that now we're bridging together this trace, the black, which is the ground pin, and this part here, which is green, noted as, and it's the left pin. So in this situation, when this is flat, the Atari or whatever video game system is reading this input will effectively recognize it as a left input. So these contacts are put over top of all these areas. Now, what holds them in place? Well, believe it or not, there is a piece of tape that is very similar to this packaging tape that sits or adheres over top of the entire circuit board and holds all the contacts in the positions that they're supposed to be. And you can kind of see some of it left over on this board over here, which I haven't fully removed. So you can imagine if I was playing a game and I wasn't very familiar with how hard I had to push in each direction, I could really be pressing hard down, left, and right. And by doing so, I'm pressing really hard against a piece of tape and this contact, and I could effectively have it move off the area. That's because there's an air gap underneath this piece of tape. There's nothing mechanically holding it to the board. So over time, it's very possible that these contacts shift underneath the tape so that they are no longer in an area that when pressed down, they are going to bridge 2 connections. or for that matter, the center is going to be off in an area that is just basically pushing over empty space. And that's what causes most of these joysticks to fail. It's these contacts that have shifted over their ideal positions on the circuit board. Here's another representation of the board, but under a digital zoom. These are the original contacts that I salvaged from this joystick, and you can see how they work by pressing down. They do flex, but there's another problem here which may not be evident under the camera. These contacts are all broken. They have cracks that have formed in certain directions due to heavy pressing or squishing by the joystick. And unfortunately, what this means is that when the contact is pressed down, it is not actually folding in the center. It folds along the crack. That is another common issue with these controllers, is that people press hard because they're not getting the response, and they end up shifting the contacts and ultimately breaking them. So two problems caused by inexpensive design processes to keep the joystick costs low. So that's a quick overview of how this board and joystick basically works. Let's now take a look at the modification. This is a very common modification that you'll find on the internet, and it basically involves installing these momentary push button or tactile switches. These are much more favorable when soldered on the board to those existing contacts, mainly because the solder connection provides a good mechanical joint, and these are not going to slip around when they're pressed. And they also have this nice little feedback mechanism that when you press them, you can feel the clicking and the resistance that they offer. They're also pretty strong, so they're not going to break if you press down on them too hard. I chose to use the smaller versions of these tactile switches. I've got a bunch of them that I use for varying projects, but you might also notice that there are other types, mainly that have 4 legs, and they come in different sizes. I chose to use these ones because obviously these are smaller than these ones over here, but you could go ahead and use the smaller versions of the 4-legged connectors as necessary. Just one word of caution is that on these 4-legged tactile switch connectors, that pairs of these legs are connected together. So when you do solder them on the board, make sure you solder across the diagonals. So this point here will go on one trace, and this point here will go on the other. Or similarly, if you rotated it, it would be this point and this point. To prepare your board for soldering, you'll first need to remove that layer of tape that's holding everything down. Then get rid of the contacts, and then start cleaning the board with some isopropyl alcohol, and that will remove any residue that might prevent a bad solder connection going forward. For these contacts, their legs are a little bit squiggly or crimped. You can kind of see that in camera. And so what I do to prepare these things for soldering is I just get some pliers and I flatten them down and then bend like so. Flatten this one down. Bend like so. And then that way, once these are perfectly flattened, they can sit on the board nicely, and you'll have a nice low profile when you mount them. Speaking of profiles, the other issue that comes up when doing this modification that's not mentioned often on the other internet resources regarding this is that once all these switches are installed and the case is closed, the case will actually start pressing down on the button itself, and you won't be able to close the case properly. So to remedy that, what I had to do is I started to file down some of these buttons. I'll see if I can get this on the camera. So you'll notice that some of these have a kind of a weird shape to them. And if we look on the corner over here, that is the correct height, which is about 2.5 millimeters in height. And if you look at these other ones, they're all filed down so that they're a millimeter or less in height. And this was just done by trial and error until I could get something that was suitable and worked very well for me in my case. And if that doesn't close the case properly, then what you have to do is you have to modify the actual plastic that comes in the joystick controller. You might remember this thing from the earlier segment, but there are 4 little stubs, 1, 2, 3, and 4 on this piece of plastic that are responsible for making contact with the old contacts that were on the board. And what you can do is you can just file this down to an appropriate height. Just use trial and error again until you get something that feels right for you. One thing I failed to mention is the fire button. And the fire button has a spring that goes on the inside, and you will not need that spring anymore if you choose to make this modification. In fact, you might also have to remove some of the plastic on the inside of this fire button if the case is not closing properly, or if the fire button is starting to actuate the button while the case closes. There's a little stub of plastic that's usually right in here, and the spring wraps around it. You can trim that down as needed. I'm in the process of editing this video, and I came across a product that obviates many of the modifications I demonstrated earlier, and I thought this video wouldn't be complete without mentioning it. Take a look at this board designed by KAZZ. It is a drop-in replacement for the existing 2600 joystick board, but uses surface mount tactile switches in place of the crappy Atari contacts. This keeps the switch profile really small, so you don't need to file away any plastic on your joystick parts. I also learned that the surface mount tactile switches are suitable for direct soldering on an existing Atari 2600 joystick board. DigiKey shows that they're about 0.5 millimeter in height, which is perfect for this application. The downside is that they are surface mount components, so they're really small and that might inhibit soldering. But that's generally true for any surface mount component, and it just takes a bit of practice to get used to. I'll have a link to these products in the comments below, as well as links to all the tools and components I used in this video. The last thing I want to show is how to determine if your cable is faulty and how to replace one in general. When looking for faults, you're going to need to use a multimeter to test for continuity between the pin on the input jack and the corresponding wire on the output side of the cable. Now, my multimeter probes aren't large enough to fit into each of these terminals here. So what I've done is I've just got a paper clip that I can use as a shim, and I've attached it to a test lead, and this will just help me probe as needed. So I'm going to take the paper clip, stick it into the probe, make sure it's firm, and attach the opposite end of the lead onto my multimeter probe. Set to continuity, test for connections, good, and start probing. So I know that this is the white wire that I should be probing, but I'm just going to check the others as a demonstration. No connection, no connection, no connection. And you would do this if you did not know which of these colors map to which of the pins. You could record it as necessary. Eventually I'll get to the white wire and I have continuity. Good. So now I know that pin 1 to the white cable is fine. However, on this cable, I know that the green wire is faulty in its connection to the output jack. Now, the green wire corresponds to the left input, and left is the third pin from the right. So if I place this in here, make sure it's firm. Again, test there. And when I go to the green probe, there's nothing at all. So this demonstrates how you would generally find a fault. You just basically go through each of the pins, recording continuity on each of the output wires. So to replace one of these cables, you have a couple of options. The first option, the obvious one, is to just get an Atari branded cable that's already made for this controller and just plug it in. You don't need to deal with a multimeter in this case because each of these wires is color-coded to a port onto the board. So for instance, the brown wire would plug into here, and the brown wire corresponds to the right input, and then the white wire would go underneath it, and so forth. The black wire, which is the ground, etc. Blue, green, orange, and you're good to go. Now, I'm paranoid, so I would be testing these things with a multimeter just to make sure I didn't buy a bad cable. But if you trust your sources, then you don't need to do that. So if you don't want to buy one of these cables, maybe they're too expensive or they're inaccessible, then your next option is to basically just build your own cable from compatible parts. And that's effectively what I've done here. The cable I purchased is often called an extension cable because it has both male and female ends on the wire. But I cut the male end off one side so I could expose the cable and then use the female end to plug into the back of the console. This style of jack is called a DB9 connector. You might see this listed on eBay as a Sega compatible or Atari compatible cable. All of these work as long as you have this style of 9 pins on the end. So because these cables are generic and that they can work with several types of consoles, you'll often find that they have exactly 1, 2, 3, 4, 5, 6, 7, 8, 9 wires inside. Now the Atari 2600 joystick only needs to use 6, so you will have to probe every single one of these ports to figure out which wires on the other end are matching and which wires you actually need to use. Now, if you recall from the pinout I listed before, we're only interested in pins 1, 2, 3, 4, 6, and 8. Those are the ones that are used by the Atari 2600. On the opposing end, once I figured out which wires I needed, I cut off the ones I didn't, and I soldered Spade connectors to the ends of the wires. You don't have to solder them. You can crimp them if you have an appropriate crimping tool. And I've also found that the size of Spade's connector really doesn't matter that much as long as you can fit it on the board. I used 0.1875 style Spade connectors, which I happen to have on hand, and I believe that is what, 3/16 of an inch. One thing I noticed is that if you get your typical Spade connector, it will not immediately go on to the board. It will not slide on as nicely as the ones from the Atari joystick. But that said, I noticed that you can just modify this quite easily. These terminals on the end of the Spade connector, you can bend them out. So I have a tool on my Swiss Army knife I can put in here, and this could work with any screwdriver. Just insert it into the end of the Spade connector and work that end up. So you'll see that it rises a bit, and keep doing this until you get a pretty good separation, an adequate separation. That looks about right, and it should be able to slide right back onto the board. There we go. Piece of cake. Now the last thing I've done here is this contraption. And this is a strain relief that will effectively emulate what was on the original controller. And the way I've built this is with some heat shrink tubing and an old shoelace. You don't have to use a shoelace. You can use any type of nylon material or any type of nylon cord, as long as you can wrap it around the wire and secure it. Let me show you how that's done. So what I want to do is I want to start by having a little bit of an end on one end and wrap it around. And then what I'm going to do is I'm going to start wrapping over top of what I've just done. And that will help secure this loose end to the actual cable. This is just there so I don't have to tie any knots and have any unnecessary bumps in the strain relief that I'm going to create. So I'll hold this down like so, and then I'm going to wrap over like that. You'll see that I'm covering my over top of my steps, and sometimes the wire gets a little or the wrapping gets a little bit loose. So just start again until you have something that looks nice and tidy and is pretty secure. Once you've gone over top of the loose end that you have covered, just continue to wrap for about 1 or 2 inches, depending on how much of a strain relief length you want on the other end of the cable. Okay, this is, well, make sure it's tight. Okay, that should be enough for demonstration. This could have been done a little bit better. I could have tightened that a little bit more, but I think you get the idea. And then once you're done, you basically just want to construct a small knot on the other end. So, how does this go? This way, like that. All right. There we go. So that loops in. That's pretty tight in there. Okay. Cut off any material you don't need, and then once you're at this step, get a piece of heat shrink tubing, slide it over your cable, and cover the strain relief mechanism you just created. Make sure that you have a long enough piece of heat shrink tubing to secure this component, because if you don't, you're going to have bits of wire or bits of shoelace or whatever nylon material coming out the outsides. I did a pretty sloppy job on mine, and I would do it again, but it's kind of working and I don't want to take it all apart. And it also might help if you put the heat shrink tubing onto the cable before you do this. Otherwise, you might have to be moving over things that are getting in the way. It just makes for an easier application later on. One last option that you have if you don't want to deal with figuring out which of these pins goes to which of these wires is to basically use one of these components. And this is just the DB9 female end of this cable, but when you open it up, it has this module which has a bunch of screw down terminals. So in essence, you can get whatever cable or whatever wire you want and place it into the necessary pin headers. So again, pins 1, 2, 3, well, this side, 1, 2, 3, 4, 6, and 8. And because you know which wires you put in there, then you'll know on the other end which wires go to the necessary parts of the board. It might be a little bit easier. It's just another option for not having to use a multimeter if you don't have one. All right, the last thing to do is to put everything back together. First thing you need to do is to take these components and somewhat wedge them into the back here so that you can secure the cable into the strain relief mechanism that's inside the case of the joystick, and then attach the spade connectors to the board on the inside. Once the cable's in there, go ahead and start connecting the spade connectors to the circuit board. And I kind of cheated in advance. I wrote down on the back of my circuit board the color mapping so that I don't have to memorize this. Okay, one thing I forgot to mention is that because of this part here of the top part of the joystick, it might be difficult to close the whole contraption when you build one of these strain relief mechanisms. I forgot that this component here actually presses into the wire to hold it in place as an extra method of security. And so as I was trying to put this back together, I was kind of futzing around with it, trying to figure out why it wasn't closing properly. And I forgot that it was because of this. So it's perfectly natural to press down and clamp it a little bit harder than you're used to when you've built one of these mechanisms. So I'm going to close this case up now and finish things off. Okay, it's not perfectly closed. I'm holding it down with my fingers in my hand, and before I seal things up, I just want to make sure all the directions actuate properly and that none of the buttons are actually being pressed down before things are closed. So if I press up, down, left, right, I should hear the little tactile switches click. That's good. Fire button's okay. Everything feels good. All right, time to close it up. Okay, one last test to make sure that the screwing and the clamping has not pressed this thing into the switches. Up is good, down is good, left is good, right is good. So this is sticking a little bit, so I might ease off some of the screws just to get that fixed. Yeah. Much better. All right, well, that wraps things up for this video. I hope you found this information useful. And if you have any comments or any suggestions for future videos, please feel free to note them in the comment section below. In a future video, continuing with the Atari 2600 theme, I want to talk about this game, Star Raiders, and the special controller that had to be used to play that.